Lesson 4.2, simplifying algebraic expressions. So first of all, we got to figure out what algebraic expressions are. They are combinations of numbers and variables and math operations. So what I have there listed, 4x plus 7 minus 2x plus 1 is definitely an algebraic expression. And there's lots of vocabulary that you need to learn from algebraic expressions. And part of the assignment that you'll do, you are just naming these things. You don't have to do anything else with it. So I want to point out to you each one of these things. First of all, terms. Terms are every section of the expression. And we're going to list these, separating them by comma. Whatever sign is in front of that term, it's attached to it. And you'll see when we get to the 2x how we do that. So this expression has 4 terms, and here they are. 4x, 7, negative 2x, and 1. So notice you don't have to write the plus signs, but with the 2x you do have to write it as a negative 2x. So terms are every section in the expression, anything separated by the pluses and minuses. Coefficients. Coefficients are the numbers in front of the variables. So we only have 2 terms with variables, so there's only 2 coefficients, and that would be 4 and negative 2. Notice you still got to call that a negative 2. And like terms are the ones that have the exact same variables. Well, the exact same variables, so we have actually 2 sets of like terms in this expression. The first set is 4x and negative 2x. That's one set. I'm going to separate the sets with the semicolon. The other set that has the exact same variables are 7 and 1. What variables do they have? None. So those that have none are like terms also because they have no variable. Constants are plain numbers with no variables. We just said those. We have 2 constants, 7 and 1. Okay, questions about that vocabulary. You need to know what constants are when we talk about like terms, what those are. Coefficients. Coefficients are numbers are in front of the variables, and be able to name every term, so every section. Okay, it's important to know what like terms are because when you simplify algebraic expressions, you're doing it by combining the like terms, and you combine the like terms by adding coefficients together. So when we have this first problem right here, it has 8n plus 4 plus 4n minus 1. We need to simplify it. So when you have something completely simplified, there are not any like terms left. They're already combined together. That's what makes them simplified. So you go through and you look, 8n and 4n should match. So you would take 8n plus 4n and you would have a total of 12 n's. You add the coefficients. The n doesn't change. There's 8 n's plus 4 n's. We've got 12 n's now. The other like terms, the 4 and the negative 1. So if I have 4 and I go back 1, that would be a plus 3. So 12n plus 3 is a simplified answer. You can't go any further because the number with an n can't be matched with a plain constant. So what you're going to do today is you're going to combine things together that have the same exact letters by adding their coefficients and then writing what's left. Generally, you want these to go in alphabetical order if there's more than one letter, and you want the constant at the end. Okay, any questions about that one, 12n plus 3? So I'm going to scroll down here a little bit before we get to that one on the right. I'm going to do the one down below it. Yes. I should bring it up here. Okay, so we already did that first one. Let's do the one right here. So 6x plus 4 minus 5x minus 7. Does anybody want to try that, simplifying it together? Haley, what do you think?
We need to add together the 6x and 5x.
Right. So it's positive 6 and negative 5. So I have 6 and I go back 5. And what would that be?
1x.
1x. And then what else needs to go together?
The 4 and the 7.
So I have 4, but I go back 7.
Negative 3.
Yeah. Now, on this one, you can write it like that, or we probably should get in the habit of not writing ones in front of your variables. So we would want to go ahead and say x minus 3. Very good. Okay, what about this one? 9a minus 5 minus 2a plus 8. Stephen?
First you would add up the a's.
Okay. 9a minus 2a.
Which would be 7a.
Right.
And then negative 5 and positive 8.
Which would be?
Positive 3.
Yeah, so 7a plus 3 and you'd be done. Okay, we're going to switch to this one over here on the upper right. I've got parentheses, which means we have to take what we did yesterday and distribute before you can combine like terms. So let me do this one. I've got a y that I'm just going to bring along because I can't do anything with it yet. And then I have a negative 2 out in front of this parentheses. So I have to take negative 2 times x, which makes it negative 2x. And then negative 2 times negative 3y. Well, negative times negative makes it positive. 2 times 3 is 6, and then there's a y there also. So negative 2 times negative 3y makes it positive 6y. Okay, so I have two different letters. So what I'm going to do is I want to go alphabetically. X should come first. There's not like terms with x, so you just write down negative 2x. And then the y's come next. Well, there are a couple of those. What number is in front of this first y? Anybody know, Trayton?
1.
1. So 1y plus 6y would make it 7y. Good. So negative 2x plus 7y. Okay. Just for the sake of sticking with distributive property, I'm going to go down to this one now. Negative 3 times the quantity m minus 1 plus 2m plus 2. So, does somebody want to try this one now after we just did Trayton? So let's distribute first. Okay. Oops. And then negative 3 times negative 1. Yeah. And then you just go ahead and bring the rest of the problem down for now. So he's got negative 3m plus 3 plus 2m plus 2. Good. What? Oh, I'm going to let him finish. So negative 3m plus 2m. Trayton, what do you think?
Negative 5m.
Well, I have negative 3. I'm in the whole 3, but I gain 2. So negative 1m. I'm going to put just negative m. Okay, and then what about 3 plus 2? Plus 5. Negative m plus 5. There you go. Alrighty. So, here we go. Over here on the right. This one I did just because I know there's one like it. A plus A plus A plus A plus B plus B plus B. Anybody want to try it? Austin, what are you thinking?
4a plus 3b.
Yeah. They all have ones in front of them. So just add up how many there are. Write that number in front of each letter. Put it in alphabetical order. You're done. 4a plus 3b. Questions about any of that? You think you can do this? Okay, we need to look at a couple of word problems because we're going to be doing a few of those. Okay, so here we go. And we are writing expressions and simplifying them. That's going to be the job with this. So hopefully you got this written down already.
I didn't get this.
I didn't even see.
Is it a
Well, you can go back and write the problem, leave a little space, because we want to get to that Kahoot. So, Matt has Y shoes. Bob has 5 fewer shoes than Matt. How many shoes do they have together? So, here's how I want you to set this up. I want you to talk about Matt and Bob. So you're going to write that down off to the side, okay? Matt has Y shoes. So for Matt, I'm just going to say Matt equals Y. If Bob has 5 fewer than Matt, Tori, how could I write that? If Matt is Y, how could 5 fewer than that look? What minus 5? Y minus 5. That's exactly right. Does everybody understand? 5 fewer than Matt, so 5 fewer than Y. Y minus 5. How many shoes do they have together? So what you want to do is Matt plus Bob. So Tori, what would that look like if I'm writing it with the expression? Y for Matt. What should I put in there for Bob, though? What's written for Bob? Bob equals what? No, Y minus 5, right? So Matt is Y, and Bob is Y minus 5. So you put those both in. Now, Tori, can you simplify that for us?
2y minus 5.
Yeah. This is what you're going for right here, 2y minus 5. I would put both things listed to say what they are. There should only be whatever letter they are referring to. So in this case, Y. And then how many do they have altogether? They want you to add those two things together. And that would be what you do for a simplified answer. Questions about that? That takes a little more thought. Okay, we've got one more. This one talks about, I don't know if they're brothers, but they're all J's. John, Joe, and Jim. And they're eating pizza. So you do what I said before. I would write John, Joe, and Jim. And we'll see what they say about it. So John ate M pieces of pizza. So there you go, M. Joe ate twice as many as John. So how could I write an expression for Joe? Jessica?
M times 2?
Yeah. So I'm going to just put 2M. M times 2. Good. Jim ate 3 more than John. So Jessica, do you know what I might put for that one? If Jim ate 3 more than John?
2m plus 3.
Go back to John. John, they kind of tricked you. John just is M. So,
M plus 3.
yes, M plus 3. And now it wants, how many did they eat all together? So that means we want John plus Joe plus Jim. Jessica, you want to finish this out for us? What should I put in for John? M plus Joe, 2M, plus Jim, M plus 3. Now we need to simplify like we were doing before. So what could I simplify that to?
5m.
We've got M plus 2 plus M,
6m.
not 6. So there's, how much is in front of this M for John? 1. And then there's a 2M for Joe, and then a 1 for the Jim. So 1 plus 2 plus 1. 4M, and then what's the rest of it? Plus 3. Good job. That was a good job. 4M plus 3. So describe each person, however they say in the description, as the variable. And then when they want them all together, you would just add them all together. Questions about that?